Hi everyone. All right, so today we were going to work on dilations. Of course, obviously I'm not here today. So I'm leaving you guys this video to kind of serve as our same discussion piece to kind of get you started on the work. So as you're watching this, you should have a piece of graph paper in front of you. If you don't, pause the video, go get one. And we're going to do two problems together, and we're going to start off with number 13. I'm thinking this will be a good one to help you with this idea of dilations. And then we'll do one other, and then the rest of the time you're going to be working on the rest of the assignment. I want you guys working in your assigned seats today, no switching into groups. A couple days we've had some kind of rowdy behavior, and you've got a sub today, so I want you guys on a little bit better behavior today. So stay in your assigned seats as you work and you finish this video and you transition over to today's work, okay? All right, so here's what I want you guys to do. We're going to start off with number 13, and we're going to try to apply this idea of dilations and scale factor that we saw in the tutorial video. So number 13 right here, they want us to start off by graphing this triangle with these three vertices. K is, like we've been seeing, K is what's called the scale factor, so we're going to enlarge things by a scale factor of 4. All right, so what I would do first off, before you get started, notice that if we increase things by a scale factor of 4, we're going to be going up to like 4 times 4, which is 16, 3 times 4, which is 12. So before you do your graph, here's what I might suggest today, because this might happen once in a while. When you do your graph, just make your standard X, Y axes, but 16, even though this is a really big graph, it's going to go off the page, and you don't want that to happen. So just so you know, in my class, here's basically my guidelines. If I get a graph like this that is not labeled, I am assuming you're going by ones, that this is 1, 2, 3, 4, and so forth. But in this case, I think we'd be better off, rather than doing a bigger graph, let's scale our graph by 2s. Okay, now if you are going to go by 2s, here's what I want to see. I want to see that you've labeled at least the first 3 or 4 with the by 2 numbers. 2, 4, 6, 8, 2, 4, 6, 8. Okay, for me, this will be enough. At least that I can see that you're starting off from the origin, going off by 2s, and you don't have to label the entire thing. Okay, this would be enough. Okay, or if you don't want to do this, what you can always do also is over to the side, just put in parentheses, go by 2s. Okay, this lets the viewer know that this graph is supposed to go by 2s and not by 1s. Okay, so either of those two options. All right, so why don't you guys go ahead, pause the video, and graph for me A, B, and C, and make a triangle out. Okay, number 13, graph those, pause the video, and then come back. Okay, so at this point you've graphed it, and I'll graph mine really quick. It should look something like this. 1, 1 is right there since I'm going by 2s. 1, 4, and 3, 1. Okay, what I would also do, get in the habit of labeling which one's which, because a lot of times it's important to know which one's A, which one's B, which one's C. So in this case, my picture, oops, off there a little bit. My picture should look like this. That's A, this one's B, and this one's C. All right? Okay, so now what we're going to do is we're going to do a dilation. In this case, an enlargement. Now, how do I know it's an enlargement? Well, it's because of the scale factor here. When the number is greater than 1, I know it's an enlargement. This is telling me I'm going to make my enlargement 4 times bigger. As you can see on some of the other problems, they're less than 1, like this. A scale factor of 0.5 would indicate that it's going to be a reduction, and it's going to reduce it by half as much. Here, this would be a reduction of 1/4. Right here, this would be to triple the size, an enlargement. Okay? All right, so we're going to do an enlargement by 4. All right, and the best way to do this is to just basically look at the coordinates. Okay, we call it a scale factor, and factor implying multiplication. So all we have to do is this. For A, we take our coordinates 1, 1, but we multiply them by a scale factor of 4. So 1, 1 times 4 would be 4, 4. So A prime would be at 4, 4. So I mark that point, and I label it A prime. We use that little apostrophe mark. And all you have to do is the same for all the rest. Let's go to B. B was originally 1, 4, but after multiplying it by a scale factor of 4, just do the computation in your head, you should get 4 16. So again, if I'm going by 2's, 4, 8, 10, 12, 14, 16. So there's B prime. And then finally, go ahead and do C. C originally was 3, 1, multiplied by a scale factor of 4. And what would that be? Okay, if you did the mental math right, that would put C prime at 12, 4. 8, 10, 12, 2, 4. Okay, so when you connect all your points together, if you've done everything correctly, then you should get a similar triangle to the original one. Not only that, it should look exactly 4 times bigger. And that's our dilation. Now, one last thing that you don't have to write down, but I think it's important, is on this one, that there's also this idea of the point of dilation. And the way I like to think of it is, think of this orange one as the original object. Think of this one as the shadow that it's casting. And the light source is the origin itself. I'm going to label it in red here. Okay, if you've done it correctly, an easy way to check to make sure everything's right is to line up your points. Like, for example, I'm going to line up A and A prime. Here's A prime. If I line them up and draw a line, that line should also cross through the origin right there. I'm going to do the same thing with B and B prime. If I take B and B prime, line them up, that line also goes to the origin, and the same thing with C and C prime. So the way I like to think of it is like it's like a projector or a flashlight. If the origin's the flashlight shining on the original image, the copy is just its shadow, and it almost feels like has like a three-dimensional feel to it. But that's how you can tell whether or not you've done your enlargement or your reduction exactly. Okay? All right, oh, and one thing we forgot, we already identified this was an enlargement, so we should write that down, enlargement, because the scale factor was bigger than 1. Okay, so that's number 13 finished. Okay, you graph your shape, you look at the scale factor by which you enlarge things, you multiply those coordinates by that scale factor, it gives you the location of the new shape, and the new shape should be proportional and similar to the original. Okay, so that's number 13. Let's do one more. All right, next one we're going to tackle is number 22, and we're literally going to see if we understand this forwards and backwards. Now, in this case, what I mean by backwards is that they've done the problem for us. We have to backtrack and figure out certain things. They want to know what type of dilation this is, and they want to know by what scale factor was this dilated. Now, the first thing you need to identify, though, is which one's the original and which one's the image. Now, I'm hoping everybody in class knows this because we've done this before, and this is something we've talked about again and again. All right, if you look carefully, look which one has just the normal letters, which one has those prime marks. Okay, so in this case, the ones with the normal letters, that's the original. Okay, the red figure, JKLM. So the dilation is J prime, K prime, L prime, M prime. All right, and so by seeing that, well, that must mean that if this is the original and it expanded out to here, this must be an enlargement. So let's go ahead, write this down. 22 is definitely an enlargement. Okay, now if I go back to the instructions, the blue figure is a dilation of the red figure. They told it to you, but I still wanted you to be able to identify the original and the copy. All right, next, identify the type of dilation and find the scale factor. So the type of dilation is an enlargement. Now we just need the scale factor. Now, there are two ways to do this. Okay, I'm going to show you both, and you can work with whichever one you like. Okay, one way to do this is to just pick a point. I'm going to pick point K, right here up in the corner. Now notice this graph goes by 2's here. So K has the coordinates of 4, 4, and K prime has the coordinates of 6, 6. Okay. Now, to find the scale factor, it's pretty much matching up corresponding coordinates, in this case, 4 and 6. Now, the question, though, I usually get at this point, well, Mr. Honda, should the scale factor then be 4 over 6, or should it be 6 over 4? All right, well, the answer to that is up here. Okay, we've already figured out that this is an enlargement. Okay, and with enlargements, the scale factor ratio should always be a number bigger than 1. Okay, so if I take a look at these, and actually I should reduce them too. So this reduces down to 2/3, this reduces down to 3/2. You have to ask yourself, well, if it's an enlargement, which of these is bigger than 1? Well, it's this one. Okay, we don't want to use this one because 2/3 implies that we're shrinking it to 2/3 the size. We're trying to make it bigger. So we're going to go with the ratio that's larger than 1. 3/2 is the same thing as 1.5. All right, so that's our scale factor of k. Now, that was one way to do it. Now, here's another way to do the enlargement. If I go back to the picture, another way you can do this is just to pick a side. Let's say I pick this top side right here, jk. So jk, since this graph goes by 2's, jk has so the measurement of jk has a length of 10 units. Now, if I look at the measurement of j prime k prime, and it goes by 2's, 2, 4, 6, 8, 10, 12, 14, 15. All right, so this is a different way to do it. I'm just using the side ratios to get my scale factor. Now again, I need it to be bigger than 1, so the way I'm going to set this up is I'm going to put the 15 over 10, which, just like we've already found out, if I divide by 5, also reduces to 3 over 2. Okay, so for your work today, you don't need to do both, but I want you to pick one that makes sense to you. So either go by a point and its image point and use the coordinates to find your scale factor, or pick a side. Pick a side of the shape, pair up those sides, and find the scale factor that way. All right, so this is the type of work you're going to do today. I think those two problems should help you. Okay, so that takes care of 13. That takes care of 22. Okay, the rest of the assignment will be up on the board. Just keep working on that same piece of paper, and this is what I want you working on for the period. Now, once again, I want you guys in assigned seats today. Sub probably doesn't know a lot of names, so I want you guys seated by the seating chart, and just help each other out, okay, and do good work today, because don't forget, we got that test on Tuesday. I want everyone to do really well. All right, good luck, guys. Work hard.